Welcome to this fourth video of the step-by-step series about modeling a bond wire layout using MFis wire. You see here the geometry from our last video. In case you didn't follow our last video, you can find the file at the same place as this video on our webpage. So this video is about creating a bond wire layout, which will draw some bond wires. So let's first start by creating a template for our new wires. So this is the Manage Template button. So there is always template 1, the default template. This is just a copy of the factory defaults. Factory defaults you cannot edit, but template 1 you can edit. We can now just use this template, rename it. Let's name it Power Wires. And the only thing you might change is the reference for the bond height. So we want to bond from the diode chip to the IGBT chip to the substrate. The loop height should be specified with reference of the substrate surface, and it is the destination bond which is on the substrate surface. So we have to change it here to destination, and the height reference will be with reference to the destination bond. That means substrate surface. Okay, we have now this template. Now we just create a new layer. So the layer is called Power Wires. We make this the current layer, and we can start drawing a wire. So we just select the wire bond tool, a stitch wire, this one. Since this layer is not yet associated with a wire layout, we are asked whether we want to create a new one. Let's create a new one, and we can select the parameters. So we can choose between wall bonding and wedge bonding, and select the diameter, and there are other parameters. The meaning of all these parameters is explained in a separate video. So let's just take the default values and click OK. So now we are drawing a wire. We snap the end of the corners of the area we are allowed to bond. And now, perpendicular to here, you have to make sure that end and perpendicular, these ones are activated, and then you're able to snap to these locations. Now we are finished. We just hit enter and our wire bond will be drawn. Okay, we did forget to specify color for the new layers. It's now all the same colors. So we should, best is if you do it before, just on this layer, and then when you create the wire, the sublayers will have the same colors. We can now just select all these layers and adjust the color. I want to make it blue, and not a strong blue, a slight blue, like this. Okay, yes. Okay, and now I want to move this inside the gate pad, inside the bond pad of the substrate. So I just can select the bond point. I can select it by dragging a box around it, or I even can select it when I hit it, but the problem is I don't see it well. So what you can do is you can also switch to this mode, the wireframe mode, and then you see the point. You can select it here. This is an option, but I like more this mode. What you can do also is you can here turn off the WirePolysrf layer. So there are sublayers created for the individual wire objects. So the first is the wire definition. Wire definition contains these wire definition objects. WireCrv is the center line here. This center line, and WirePolysrf is the surface of the wire in the 3D representation. So you might also work in this mode, then you can just easily see the points and select, and then move these points. I most like this mode, like this. Okay, now we can select the gumball tool. this allows us to just easily move by a specified length in a direction. I select this Y direction and I apply -1.1, and it is now inside. Okay, we see now that our object is turning. We can turn off this terminal layer and also the termination layer here. Okay, so this is our first bond wire. We want now to create a row of bond wires. So we select the wire definition object. Okay, now we see we could now select either a sketch element or the curve. Best is to lock the sketch here, and then this doesn't happen. Now we cannot select the sketch. Now if you click here, it's clear it is the wire. Okay, now I use the linear array tool. I must specify the number of items. I don't know in advance how many will fit there. I'll make 15, enter 15 and enter. And now I have to give a direction. I click somewhere, doesn't matter where, here for instance, and then I can define the direction. I can also define in the other direction, or even if I hold the shift key, I can do any direction. And I want the defined length, so the minimum pitch I want to have is 0.9 millimeters. Okay, I click and now the row is built. And now I see there are some wires which are not within the allowed area. So these 4 wires, I can select them and delete them. Okay, now when we look from the top, we see that the wire distribution is not uniform. So at the end there is a unused space on the IGBT, also on the diode a bit. So let's now change the pitch. So I select all the bond points on the diode. The gumball I turn off, I don't use it now. And now I use the 1D scale command, this scale 1D. I can specify initial length from here to here, and change it to a new length until here. Now it fills the whole bondable area. Now the same on the IGBT, and I also do it for all the bond points on the substrate, like this. I also use the scale 1D, where is it here, scale 1D command. I snap this point, and it should scale to the end point here. Great. Okay. And now we need to free up some space that we can reach the gate pad here. So I just select the first 6 wires, the destination bonds, and again I use the gumball tool, -2 millimeter, and it moves to the left, and these wires I'm moving to the right. Okay, and now here these bond points must move to here. I select these 3 points. I don't use the gumball here. I'm using the move command. That's this command, move. Just click here, then select a source point or reference point, this one, and then where to move this. So I can snap to this line using the perpendicular snap. Okay, now we should reach in between here. Yeah. Okay. And we are in a situation here that we have a lot of space here. This is very rare when you are designing power modules. Always you don't have too much space, but now we are glad that we have space. Let's spread a little bit here the bond wires. We change the pitch here. First, let's measure what is the pitch between these wires. We have here a measure tool, measure distance. With this I can specify 2 points, and here it is displayed the distance is 1.06 millimeters. Let's change this to 1.2 millimeters. Again, we do it using the scale 1D command. I specify the first point, the center of the scaling, and the second point, and I give a length for this 1.2. Hit enter, and it is scaled. And on this side, okay, we need here space for the other IGBT. I want to save a little bit of space. I can do it by making a staggered layout. I select this point, and then with holding the shift key and making a selection box, I select the second point. Now I'm using again the gumball. I move this to by -1 millimeter in Y direction, and now I can shrink the pitch a little bit. So let's first again turn off the gumball, then measure the pitch from here to here. This is 2.12 millimeter. Let's change it to 1.6 millimeters. Again, using the scale 1D command, from here to here, 1.6, enter, and we have now a more narrow arrangement. Now I can just adjust the position of these. I could again use the gumball, but there is also this tool. It moves by 0.1 millimeter. You might also adjust how much it moves. You can right click here, edit button, and this one. And this is basically just a Rhino script. You can just adjust here. Instead of 0.1, you might adjust it to 0.2 or whatever, and click OK, and you have adjusted this button. You don't need to use the buttons. You can also use Alt and arrow key. No, in my case, it's not the standard setting. Okay, let's go to the settings. You can shift points or geometries. You go to Rhino options, modeling aids, nudge. Nudge means this shifting, and the default is with Alt and arrow keys. You can shift your geometries, and I prefer only using the arrow keys without Alt. And here you can specify the length for the nudge command. So default is 0.2 millimeters. I change it to 0.1, and here's default don't know what, so I put it to 10 microns, and here to 1 millimeter if you have the shift key. So I demonstrate it now. I can now just use the arrow key to move 0.1 millimeter or 10 microns using the control key. Moves just a little bit. You can also watch here how much you moved, even the cumulated. The output here is very useful. Very often you can read the output to see what's going on. Or I can hit Shift and arrow, it will move by 1 millimeter. Or only arrow now, it is 0.1 millimeter. And now I'm quite happy with this. Okay, great. This has been the first part of modeling a bond wire layout. We will go on with the control wires in the next video. I hope to see you there. Have a great day.